call this section Fun with Factoring. The goals, two goals, to factor out a greatest common factor, that's your first goal, and to factor by grouping, that's your second goal. Again, you've seen both of these methods before, so this is a refresher. It's not supposed to be the first time you've learned it. So here's the question, cue for question. What does factoring a polynomial mean? Well, what does it mean to factor a number? If I write down the number 12, can you give me a factorization of 12? What is it? Or what? There's more than one answer, but what is one answer?
2 times 2 times 3.
Okay, well that's actually called the prime factorization. Yeah, so that's actually unique. The prime factorization is unique. So that works. Another factorization is like 2 times 6 or 3 times 4. And they're all equal to each other, right? Then the prime factorization is where you break down each factor into their prime factors. So 2 is a prime number. That guy's done. 6 is 2 times 3. So that's called the prime factorization. So that's a prime factorization. Prime factorizations are unique. I mean, you could reorder the multiplication, but other than that, they are unique. So back to the discussion, though. What are we doing when we write 12? A factorization of 12, like say 3 times 4. We're writing it as a product. We're writing 12 as a product of other numbers in this case, right? That's what it means to factor. You're going to write a given expression, maybe it's a number, maybe it's an algebraic expression, as a product of other algebraic expressions. So that's what it means to factor a polynomial as well. So what does it mean? What does factoring a polynomial mean? It means you write the polynomial, I'll say poly for short, as a product of other polynomials. That's all it means, you guys. So when you finish your factoring, you better have a product. You better have quantities multiplied together. If in between quantities you have a plus or a minus, it's not factored. Let's factor out the greatest common factor, and I'll never write that out again. From now on, I'll say GCF, greatest common factor. So you guys know what the greatest common factor of numbers are, right? So what would be, just taking the 6 and the 12, the coefficients, what would be the greatest common factor of 6 and 12? What do I mean by that? It's the biggest number that is what? Yeah, it's a factor of both of them, which also means it divides into both evenly. So what's the greatest common factor of 6 and 12? You could denote it like this, GCF and then parentheses 6 comma 12. So that's going to be 6, isn't it? Yeah. Okay. So what do we mean when we say factor out the greatest common factor of a polynomial, like in part A, 6t squared minus 12t? Well, we're going to factor out the greatest common factor of the coefficients, 6 and 12, which is 6. And we're going to multiply, to get the GCF of the entire polynomial, we're going to multiply that 6 times the GCF of the powers of t. Okay, so what do you think, taking the t squared and the t, so we've got two terms, one with a t squared in it, one with a t. What do you think the GCF of t squared and t would be? It would be if you have like bases like we do here, it's going to be the base to the smaller exponent. This is t to the 1. When you don't see it, the exponent's a 1. So the GCF of t squared and t is just t. Now that should make sense to you also because t squared contains 2 factors of t, right? T squared is t times t. And then of course, t contains 1 factor of t. So what's the factor that's common to both of them? T, and it also happens to be the greatest common factor. Now, what if it just, this it doesn't have anything to do with this problem, but what if it had been, say, x to the 6th and x to the 4th? What would the GCF of those two guys be? X to the 4th. You just take the smaller power because both x to the 6th and x to the 4th contain a factor of x to the 4th. Does that make sense? Okay. All right, so now let's do the first problem. What would the GCF of 6t squared minus 12t be? Yeah, you're just going to take the GCF of the coefficients, which we already know is 6. The GCF of 6 and 12 is 6. And then you're going to take the GCF of the variable part, which is between t squared and t, and we already know that's t. So that is your GCF. And then remember, the idea is to kind of reverse distribution here. Instead of multiplying out 6t, we're factoring it out. And what's going to be left from the polynomial 6t squared minus 12t if we take a 6t factor out of both terms? Yeah, there's a factor of t left from the first guy, right? Because it was t squared to begin with. And then just a factor of 2 left from the second guy because we factored out the t. So factoring out the GCF in part A, you get 6t on the outside. That's your GCF times the quantity t minus 2. Now, can you check your answer here? Yeah, you can just distribute, right? If you distribute the 6t, you better get 6t squared for the first term. You do. Distribute over subtraction, you better get a minus 12t for the second term, and you do. So you know this factorization is correct. So that's the answer. 6t times the quantity, t minus 2. In part B, we have 16t to the 8th plus 40t to the 6th minus 24t. Let's just start, okay, we want to factor out the GCF. Let's start with the GCF of all the coefficients, 16, 40, and 24. So what's the GCF of 16, 40, and 24? 8? Everybody agree? Okay, 8. 8 goes into 16, it goes into 40, it goes into 24. Is there anything bigger? No, I don't think so. No. Okay, and then what's the GCF of t to the 8th, t to the 6th, and t? Just you take the rule is you take the small, if you have like bases, take the smallest power of that base. So 8t is your GCF. And then you just think from the original polynomial, what's left from each term if you take out that factor of 8t? What's left from 16t to the 8th? Well, just divide 16 by 8. That's a good way to get it. 2. And then think of it as like canceling one of the t's out of the t to the 8th. T to the 7th is left. You took out one factor of t, right? Does that make sense? Yeah, it's hard. You've seen harder this semester. Okay, what's left from the 40t to the 6th? 5t to the 5th. And we really are just reversing distribution, aren't we? We're taking out that 8t instead of distributing it. And then what's left? What's the operation? Minus 3, and that's it, right? Does everybody see that? And if you distribute out that 8t, you'll see you get the same thing you start with. Or you better get the same thing you started with, otherwise it's wrong. Easy enough? Okay.